It is important to understand that not every member of the population will experience the event of interest during the study period. For example, there will be customers who are still a member of the company, or employees still working for the company, or machines that are still functioning during the observation or study period. We do not know when they will experience the event of interest as of the time of the study. All we know is that they haven't experienced it yet. Their survival times are longer than their time in the study. Their survival times are thus labeled as censored. This indicates that the survival times were cut off. Therefore, censorship allows you to measure lifetime for the population who haven't experienced the event of interest yet. It is worth mentioning that the people or subjects who didn't experience the events of interest need to be a part of the study, as removing them completely would bias the results towards everyone in the study experiencing the event of interest. So we cannot ignore those members, and the only way to distinguish them from the ones who experience the event of interest is to have a variable that indicates censorship or the event of interest taking place. For example, we would assign a 0 to the customers who didn't churn during the study period, and we would assign a 1 to the customers who churned during the study period. There are different types of censorship done in a survival analysis, which will be explained shortly. Note that censoring must be independent of the future value of the hazard for that particular subject. Right censoring happens when the subject enters at time equals 0. That is, at the start of the study, and terminates before the event of the interest occurs. This can be either not experiencing the event of interest during the study, meaning that they have lived longer than the duration of the study. It can also mean that they could not be a part of the study completely and left early without experiencing the event of interest, meaning that they left and we could not study them any longer. Left censoring happens when the birth event wasn't observed. Another concept known as length-biased sampling should also be mentioned here. This type of sampling occurs when the goal of the study is to perform analysis on the people or subjects who already experienced the event, and we wish to see whether they will experience it again. For example, people who have experienced a certain disease or symptoms are brought into the study. Interval censoring happens when the follow-up period, which is the time between observations, is not continuous. This can be weekly, monthly, quarterly, etc. Left truncation is referred to as late entry. The subjects may have experienced the event of interest before entering the study. If we fill in the truncated region, then it will make us overconfident about what occurs in the early period after diagnosis. That's why we truncate them. In short, subjects who have not experienced the event of interest during the study period are right-censored, and subjects whose birth has not been seen are left-censored. Survival analysis was developed to mainly solve the problem of right censoring.